here's the crazy thing, okay? Back in the day, imagine, I've definitely said this before, but imagine being in the 1600s and, you know, it's a life or death situation. Somebody says, measure the speed of light or you're dead.
Oh
what do you
my.
do? What do you do?
Jesus, bro. That's an ultimatum.
What do you do?
Have.
Like,
Oh
think
my
about
God.
it. You don't even have a computer. You don't even have a camera. What do you even do? Well, I don't know what year this was done in, but it's definitely an insane experiment.
I don't even know. Yeah, go ahead. I want to hear this.
Okay. And this was definitely like recent, but it was like, this is just the reason I said like in the 1600s were just to put you in that space of like.
No, but wait, didn't Einstein do it for the first time? Like calculate the rough number?
Yeah, but I'm saying there was an experiment. I don't know if you know it. I don't know if we talked about it in the
We'll talk about it and
astronomy
we'll see.
episode, but listen, okay. So somebody said, okay, the Earth and Jupiter have, you know, separate orbits, and at some point during the year, or, you know, whenever it coincides with the orbit of Jupiter, the Earth is going to be moving towards Jupiter. And at a different point, when the Earth has time to rotate past Jupiter, it'll be moving away from Jupiter. And so, wait, am I thinking of this wrong?
No, you're actually thinking of it exactly right. No,
Okay.
you're right. Yeah.
Okay.
No, the way they did it. Again, I'm not okay. I haven't read up on this particular experiment, but I know it does have things to do with the Earth's orbit, Jupiter, and measuring the time that it takes to revolve. I know those properties are involved, and this was in fact done in the 1600s, 1700s.
Oh my God, no way.
This was way before Einstein, actually.
Wait, I think...
Are you mixing up like two experiments?
No, I think I am, because we definitely had a problem set where, like, Jupiter's moon... where
Wait,
it goes
I
around,
remember something like that.
Yeah. Like there's Jupiter's moon, and then when the Earth was going towards Jupiter, like the what's it called? Like, you know, when a
No, I know what you mean. No, I know what you mean.
I can't think of the word.
Can't say the word. No, but I know what you mean though. But we did do a problem like that actually. But I don't know. I mean, that doesn't have anything to. I mean, it's not directly to do with this, but that is how I believe it was. Something like that done, because I mean, if you think about it, at that time, you have to understand that people were, light is either two things. Light is either infinite speed or it's just too fast to measure for us, which is what we were under the impression of.
Yeah.
For like the longest amount of time, right?
I have to search this up. But
I'm
keep going.
No, I mean, I'm just trying to think about finding the equation, or not finding the equation, but finding even the rough speed of light in the day where literally nothing was even thought about, or you're not even thinking about frames of references. You're not thinking about what the requirements are or anything like that.
Okay, I found the experiment and I was actually right.
Yeah, Romer's did. Okay, cool.
Okay, so what he did is he timed the eclipses of Io, Jupiter's moon.
Yeah.
So he estimated that the light would take 22 minutes to travel the distance equal to the diameter of Earth's orbit around the sun. And this would give light the velocity of around 220,000 kilometers per second, which is
relatively close. Which is very, very, very close.
Not bad. One sec, I need more details on this. I need more details because I remember we did this. I'm pretty sure.
I don't think.
No, we didn't do it.
Yeah, but I know what you mean. We did a very similar question where we were talking about Jupiter and its transit time, and basically trying to simply find the time it takes for some kind of signal or something like that. We were doing in our year, but again, I mean, it's really impressive that these individuals even tried to find something like this.
This is what happened. I remember. So when the Earth is moving towards Jupiter, the time that the moon was eclipsed, it took less time for the moon to eclipse Wait, is it the moon that eclipses? Yeah. Because the moon. Yeah. This is this is definitely
This is such a funny episode, man.
no,
Goddamn.
because this is actually like an insane experiment.
Yeah.
If you think about it,
1600s, you discover the speed of light.
No,
like what?
Seriously. So basically, when the Earth was going towards Jupiter, it took longer for the moon to go across than when the Earth was moving away. And so what he did is he calculated the difference between the times, and
He just did some crazy math.
Wait,
Oh, what? That's crazy. That's pretty next level. Okay, that's very impressive. Again, a lot of this was probably starting like with trigonometry. Like if you think about it, a lot of it was probably starting simply with triangles and different geometric shapes, just trying to understand the angles between all these things. And then I'm assuming estimating the speed from there. Because what I'm assuming is all of this was compared to Earth's orbit or something like that. Like it was compared to something that we were already relatively sure of. And then we got this approximate speed of light. Because again, I mean, 220 relative to 299, which is the actual speed, is very, very, very close, especially in the 1700s.
I mean, like, in terms of, like, producing an answer.
Yeah, I mean.
Very, like, who are they?
But who even thinks about it? Like, you're not, like, you light, I mean, the 1600s, like, you light fire. You're not really, I mean, I don't even understand the thought process that goes into thinking, hey, what speed does this travel at?
Okay.
Crazy moment?
No, okay. What I said was right, but here's what actually goes down, okay?
Let's hear it.
So they knew, obviously, like at that time, it was like Galileo's time. He was going off with astronomy and all that stuff and his new telescopes and all that stuff. So they figured out the timings of the eclipses of Io. So they knew when it should happen.
Okay.
So what happened was that when the Earth was moving towards Jupiter, the eclipse happened, it says, about 9 minutes early. And when the Earth was moving away, the eclipse happened 9 minutes late. So they knew that they knew the time difference between what actually should have happened, and so they were able to calculate it from there. That's just like trigonometry from there.
Yeah, if you know the distances, I'm assuming they knew some kind of distances between these planets, or at least had estimations.
You know the distance, and you know the difference between when it should have came and when it didn't, and when it did come. And anyways,
man, that's super cool.
No, that isn't. Imagine using imagine using Jupiter and the timing of the eclipses and the knowledge that the Earth has some kind of orbit and Jupiter has a different kind of orbit, and they have a relative distance between each other to calculate the speed of light. That's some next level stuff. Like, seriously,
man, like to even think of something like that.
No, I know.